Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. Today I am going to teach you input buffering. So previous class I taught you compiler efficiency is increased by using input buffering. Okay, one of the buffering technique used to increase the efficiency of the compiler. We are studying the first phases of compiler, that is lexical analyzer. So in order to increase the efficiency of lexical analyzer or the compiler, we can use input buffering. You know what is meant by buffer, right? Buffer is a small memory storage area. So what is the use of buffer we are using in a compiler designers? For lexical analyzer, we know it is used to create a tokens or convert source program into tokens. So it is converting token one by one, that already I taught you, one by one. So what is the next phase of lexical analyzer is parser generator or parser analyzer, or will say syntax analyzer, right? So it is used to convert tokens into parse tree. So in order to create a tree structure, the parser needs tokens, that output of lexical analyzer. So like I told you, lexical analyzer creates token one by one, that means single by single only it creates a token. Whenever parser needs, it asks the lexical analyzer, I need a token, by using a keyword called get next token of. So that keyword, once received by the received from the parser generator, the lexical analyzer sends next token. Okay, this is the procedure to create a parse tree for the second phase of compiler, parser generator, parser analyzer or syntax analyzer. Okay, so when the lexical analyzer create tokens one by one, it needs a memory area to store, because whenever the parser needs tokens, it takes from the buffer. Okay, that is the advantage of buffer we are placing in a lexical analyzer. Okay, so this is the concept we are using in a compiler design, input buffering, right? Buffering concept we are using in a compiler design to create a or to increase the efficiency of a compiler. How to increase the portability of a compiler? That also I taught you in the previous class. How to increase the portability of a compiler? Yes, to increase the portability of a compiler, we need a special tools. To increase the efficiency of a compiler, we need buffering. Okay, right. So there is two types of buffering techniques used in a compiler. That is, one is buffer pair and another one is sentinels. Okay, sentinels. The first we will see about buffer pair. Okay. So first you should know why we are using buffering in a compiler. What is the advantage of using buffering in a compiler? Okay, there is two types of compiler buffering. One is buffer pair and another one is sentinel. First one is buffer pair. So this is the model of the buffer. That is, we are splitting the buffer into two equal half. For example, here the expression we are using E equal to MC square. Okay, if you take this as a source code, how this is converted into token by using lexical analyzer, and how it is placing the buffer is, it is splitted the buffer into two equal half. We'll say two equal n character half. Okay, for example, we have E is a one character, 1, 2, 3, 4. Okay, 4 character is there. E 1, 2, 3, 4 character is there. So we can split into two. See, E equal to M star. This is the one character, one equal half, and remaining equally 1, 2, 3, 4, 1, 2, 3, 4. So 4, we are splitting into two equal half. And this is EOF. EOF means end of buffer. Okay, there is a difference between the EOF placing at the end of the buffer in a buffer pair. But sentinels I will teach you in the next session. At the buffer pair, EOF placed at the end of the buffer. Okay, you remember. And another one thing, EOF is not a part of the source program. I told you, E equal to MC square is a expression, or that is a token. We are treating that as a token. But I placed EOF also in a at the end of the buffer. Okay, EOF is not a part of the source program. It does not take EOF, it represents only this. Whenever the pointer comes EOF, it says that this is the end of the buffer. Okay, right. So there is a two pointer we are using here is, one is forward pointer and another one is lexeme pointer. Okay, forward pointer and another one is lexeme pointer. What is lexeme? I told you what is lexeme. That is a sequence of character, int. I will treat as an int as a token, int. This is a token or lexeme. Okay, or for example if, and whatever the keyword using, that is will say that as a lexeme, right? Okay, there is a two pointer, forward pointer and lexeme pointer. Initially both pointer points the first character of the first character placed in a buffer. Okay, that you should remember, both pointer, forward pointer and lexeme pointer, and both pointer scans the forward pointer scans the character placed inside the buffer from left to right. Okay, from left to right, clear, from left to right. First, if you take this as an example, first both pointer points E, character E inside the buffer, first character, first lexeme present inside the buffer. Okay, initially both scans from left to right, and once the forward pointer scans the character from left to right, if it is finds the lexeme match, if the lexeme is matches with the source program, and it placed in a second half. Okay, it placed in a second half of the buffer. Okay, and if the pointer moves, if it is reaches the first half of the buffer, and if it goes to the second of first character, and this point, this place should be empty, and it and the remaining next character, next sequence of character will be placed in the first part of the buffer. Clear? So because the pointer points the second half, and if the first half, if it is scanning the first half, if it is matches the tokens or lexeme, it says it is the matched token and it is placed in a buffer. Okay, second half of the buffer, and once it reaches the second half, the first half must be empty and it reloads the next sequence of character in the first half. Clear? First half, and similarly it scans the second half of the buffer, and if it is finds the character, it placed into the buffer, and when it is reaches the EOF, it says that all the scans should be over, scans must be over, and every if it is matches, every tokens must be identified and it is placed into the buffer. Okay, this is the concept we are using in a buffer pair. Clear? So you should remember the buffer should be splitted into two. It is divided into two equal n half character, and all the character equally placed into the buffer, buffer, and in buffer pair EOF must be placed at the end of the buffer and the second half end of the buffer. Okay, end of the buffer, and it scans the character, a forward pointer scans the sequence of character, if it is matches placed into the buffer, and once the first half must be completed, when it starts the second half, it deletes all the previous character from the first half, it reload the next sequence of character into the first half. Similarly, once it reaches the end of buffer, it comes to the first half of the buffer. So when it reaches the first of the buffer, second half must be empty and it placed into the next sequence of character is placed into the second half of the buffer. Okay, so this is the concept we are using in the buffer pair, and this is an algorithm. See, if forward at the end of first half, this is the first half, if forward at the end of first half, that means if forward pointer is at the end of first half, what we are going to do? Reloading the second half. We are reloading the second half. Okay, reload the second half. Then what we are going to do is forward plus 1, moving the forward pointer to the second half. Clear? So that one is over, and if forward at the end of second half, reload first half. What we are doing is we are reloading first half. Previous character is deleted and reloading first half. Move the pointer to the beginning of the first half. If it is over, we are moving the pointer to the beginning of the first half. Okay, else forward pointer, else forward the pointer. See, we are forwarding the pointer, and it repeatedly continuously doing like this. Clear? Okay, so this is the buffer pair. Okay, Next one is sentinels. Sentinels. Okay, second buffering technique is sentinels. Sentinels. Okay. So sentinel means it is a special character, that is EOF. EOF, and it is not the part of the source program. It is a special character, that is EOF, and it is not the part of the special part of the source program. Clear? It is not like this int a EOF, int a EOF, EOF. It is not like this. Only int a is a sequence of character and keyword and a variable. Only int a. EOF is not treated as a part of the source program. So what we are going to do is, at both the buffer we are using EOF. Okay, first of also we are using end of buffer, second of also we are using end of buffer. Okay, so what is the advantage by using this sentinel? That means by using this end of buffer in both half of the end of the buffer we are using EOF, right? So what is the advantage of using sentinels and buffer pair? Just you think, in EOF only one test is enough, only one half test is enough. But there, even though the token finds in the first half, it should go to the second half, because EOF present at the last, clear, last. So it should go to the second half, clear. But here if you see, if it is the matches, all the patterns are matched in the first half, it comes to the end of buffer and it goes, it exits from the buffer, clear. It no need to go to the second half of the buffer. Can you understand? Right? Once again, what is the advantage EOF present both the end of the buffer? Clear? This is the question. See, the simple answer is, in buffer pair, buffer pair, the EOF present at the end of the second half. Okay, but in sentinels, EOF present at the end of first half as well as second half. Here no need to have two tests, because in buffer pair, even though the pattern matches, it should go to the second half also. There is so two tests are required. But here, even if it is matches in the first half, it reaches the end of buffer, it should exit from the buffer. Clear? This is the advantage of using buffer pair as well as sentinels. Okay. So the algorithm is simply just only one line is differ. Here what we are going to use is, if forward pointer not at the end of first half, then it repeats the same thing. Okay, because if forward pointer not at the end of first half, then only it goes to it matches the patterns. Clear? So only the one line you have to add, that I was given in the notes. Only one line if we want to add, if forward pointer not end of first half, if forward not end of EOF, not end of buffer, then the same thing will be repeated. Clear? So this is the advantage of using sentinels and the input buffer. Okay, so this is one of the very important topic, and we know what is the use of buffer and what is the use of buffer in a compiler design, especially what is the use of buffer in a lexical analyzer. Okay, thank you.